In section 3.5, we take a look at the library of functions and shifting them around the axes, stretching and compressing and reflecting them. So it's really all about transformations of this basic library of functions. So a gentle reminder of the 7 library of functions you're supposed to know. I call these our toolbox functions. So think of these as functions that you have in your toolbox that you know quite a bit about already. So we have our identity function, that was f of x equal to x. It goes through the origin, has a slope of f1 over 1. We're going to consider its anchor point to be 0, 0. We have our friend the parabola, f of x equals x squared. Its bottom is at the point 0, 0. That would be its minimum, and that's going to be the anchor point. And when I say anchor point, what I'm talking about is the point that we're going to use to move the picture around with. So it's the one that anchors the new location. We also have the cubic function, f of x equals x to the third. That's that S shape. Again, it goes through the origin, and we use that as our anchor point. We have the absolute value of x. That's that nice V shape. Its anchor point, which is its minimum, is at 0, 0. We have the square root function. We're going to use its anchor point also at 0, 0. Looks like half a parabola turned sideways. We have our cubic function. We'll use 0, 0 as its anchor point. You'll notice that it looks like the S function, but again, turned sideways. And finally, we have the reciprocal function, 1 over x, which I call a bow tie function just because we need a name for it. And it kind of looks like a bow tie turned sideways. So it really doesn't have any anchor points. It does have the point +1, +1, and -1, -1. So you could use those as your anchor points, and you could even both of them, correct? And those are our 7 functions. So what we're going to do is we're going to actually use the graphing calculator. If you don't have a graphing calculator, then download the free Desmos app, DESMOS, in order to be able to use that. It just helps us to explore the functions and their shifting, where we can do it that way. So what we're going to do is we're going to use the quadratic function, f of x is equal to x squared, to explore what happens. And what we're going to explore is what happens when we add 1 inside the function, what happens when we add 1 outside the function, what happens when we put some negatives in, what happens if we put some constants on it, those kinds of things. So the first thing we're going to do is go ahead and graph f of x equals x squared. We just had it on the board. We know it looks something like this, and it goes to the point 0, 0. Again, you can plot more points. There's one over here at 1, 1. There's another one over here at -1, 1. What we're after, though, is what happens if we take that function and add 1 outside the squaring or after the squaring. So again, what I expect you to do while we're doing this is take your graphing calculator or the app, type that function in, and see what happens. What you're going to notice is that that anchor point that was at 0, 0 is now up here at 1, 0, and it looks like this. So on the handout, there's this wonderful table. So once we've got the picture sketched, we're going to fill in with words what's going on. So over here is table 1. And we just did graph I, which was x squared plus 1. And what we notice is the graph was shifted up 1. Now there is a table 2. We're going to come back and fill that in just a minute. Now we'll work on table 1. And the next thing we'll do is what happens if we do f of x is equal to x squared minus 1. So instead of adding 1, we subtract 1. And once you graph that, you're going to see that sure enough, that anchor point was shifted down 1. So the entire parabola has been moved down. So for number 2, we're going to say down 1. So notice I have both a direction and a how much. The up and down is the direction, and the how much is the 1. The next picture or function asks us to graph the quantity x plus 1 squared. Now notice the difference on where the 1 is. Here, the 1 is outside of that squaring. Here, the 1 is inside of the squaring. So this one, on number 1, I would have considered to be outside, where this is inside. And when you graph that, something a little bit surprising happens. So it's actually going to get shifted to the left. So that point that was at 0, I should be labeling these 1, 0. So don't do that. 0, 1. This would be 0, -1. This guy is going to be -1, 0. And it looks something like this. Once you're done, you can see the shifting. So for the third graph, we're going to say that it's gone left 1. This is where my dyslexia really comes into play. Left 1. Then positive, but we went left. Okay. So again, when we're all done, we'll draw some conclusions. Number 4 asks us to graph the quantity x minus 1 squared, and that's equal to f of x. So f of x is equal to the quantity x minus 1 squared. So when you go graph it, you're going to see, sure enough, the graph gets shifted to the right. So this would be at 1, 0. Now we're not changing the overall shape of the graph, the width of the graph, or anything. All we're doing is taking that anchor point and moving it. So in this case, we're going to go right 1. Okay, let's stop and draw some conclusions from those guys. We're going to starting on table 2. So because this was outside of the function, we're going to come over here and rewrite this as f of x. There's the function, and we're adding 1 outside or after it. This down 1 was again outside the function. So we're going to write f of x minus 1. So the minus 1 is going outside of the function notation. Now this guy, that was on the inside before we did the squaring, and it shifted it right 1. So this is inside, we're going to call it. So when I write the function notation, I'm going to write that plus 1 inside the notation. And for this guy that we have on the board still, we know that that 1 is still inside. It's inside the squaring, which is the function. We're going to write that as f of x minus 1. So we can clearly see that these guys were outside, shifting it up and down. These two are inside, moving it right and then left. Okay, well, what happens if I put a negative? So number 5 is f of x is equal to a negative x squared. When you graph that, you're going to find the picture looks like this. So the anchor point hasn't changed. It's still at 0, 0. But instead of that parabola opening up, it opens down. So it's reflected. So you can say that it was flipped down. What it really was is reflected across or over. And it's across this x-axis. So we're going to say across the x-axis. We have to be specific because we could also reflect things this way. Now on a parabola, if I switched it over the y-axis, I'm not going to see anything because it's going to fold onto itself. So in terms of the function notation, that negative is outside of the squaring. So we're going to write a negative in front of the f of x. So this is an outside. For part 6, we're going to combine things together. It says x plus 2 quantity squared minus 1. So when you graph that one, what you'll see is that it's been shifted to the left and down. So the anchor point is now here at negative 2, negative 1. And it looks something like that. So in terms of the table, we're going to say it's been down left 2, 2, down 1. That 2 is on the inside, so when I write the function notation, I'm going to write x plus 2 on the inside. The down 1 is outside, so it's a minus 1 on the outside. Number 7 says x minus 2 quantity squared plus 1. What we're going to notice is that that minus 2 actually shifts it to the right. The plus 1 shifts it up. So my anchor point is now gone to the right 2 and up 1. And again, the overall width is not changing at all. So 7, we're going to say right 2, but up 1. So when I write the function notation, because this minus 2 is happening inside the squaring, I'll put it inside the function notation. And then the plus 1 happens outside of the squaring, which is our function, so the plus 1 is on the outside. Okay, a couple more, 3 more actually. Okay, the next one, so for 8, says, what if you have a negative of x minus 2 squared and then minus 1? So we have a shift to either a shift horizontally, a shift vertically, and a reflection. So what we're going to notice is that we're going to go right 2, we're going to go down 1, but instead of opening up, it's going to open down. And that point right there is now at 2, negative 1. And again, you should be checking all of these with your graphing calculator to see that yes, indeed, that's what's going on. The graphing calculator should be what's going on first, then we'll sketch the graph, and then we'll talk about what it's doing. Well, so we went right 2. We went down 1. And we reflected over the x-axis. In terms of orders, the reflection is actually what's going on first, because if you think about that, don't you always do the multiplication before you do any addition and subtraction? So you're actually going to flip it down, then you're going to go to the right, and then you're going to go down. In terms of the function notation, that would be a negative f of x minus 2 minus 1. So the negative that was outside up here stays outside on the function notation. The minus 2 was inside the squaring, it stays inside the squaring of the function notation. And the minus 1 was outside, so it goes after it. Let's see, number 9 says, what if we have 3x squared? Well, when you go to graph that one, the anchor point is still at 0, 0. But what you're going to notice is the point that was originally at 1, 1 gets stretched up here to 1, 3. The point that would have been at negative 1, 1 is stretched up here to the point negative 1, 3. So the parabola looks narrower. So that 3 that is out in front is a vertical stretch. So I'm going to say a vertical stretch by 3. So this would really be 3 times that function. And I'm hoping you can still see that. Yes, you can. So 3 times the function. And it leaves us with one more, or 10, which is 1/3 x squared. So this time what happens, the anchor point is still at 0, 0. What's going to happen in terms of the y values, though, that 1/3 is going to take the point that was at 1, 1 and squish it down to 1/3. So this is actually, I need to be careful because I don't like to put the picture over my labeling. And over here, we're going to have negative 1, 1/3. So it looks like this. What it looks like on the calculator when you graph it is that it's wider than it was originally, and that's because we compressed. So 10 down here on the bottom is going to be a vertical compression. Vertical compressed by 1/3. So the 1/3 is out in front of everything, so we'll write the 1/3 in front of the function notation. So we have 1/3 up